Why are and, or cases tricky in absolute value inequalities? Imagine trying to solve a puzzle where the pieces can fit into very different ways. Absolute value inequalities can be just like that. They often confuse students because of how they split into different cases. When you see an inequality with absolute value, it's about the distance from 0 on the number line. But that distance can be less than or equal to a number, or it can be greater than or equal to a number. That's where the tricky part begins. Let's start with the case where the absolute value is less than or equal to a positive number. If you see something like the absolute value of a variable is less than or equal to a number, it means the variable is somewhere between the negative and positive of that number. So, it turns into a compound inequality. For example, if the absolute value of x is less than or equal to 5, then x must be between -5 and 5. You write it as -5 less than or equal to x less than or equal to 5. This is called an AND situation because x has to satisfy both parts at the same time. Now, when the absolute value is greater than or equal to a number, the story changes. If the absolute value of x is greater than or equal to 5, then x is either less than or equal to -5 or greater than or equal to 5. This splits into two separate parts. You write it as x less than or equal to -5 or x greater than or equal to 5. This is called an or situation because x can satisfy either part, not both. It creates two different intervals on the number line, one on each side of 0. The reason these cases are tricky is because students often get mixed up about when to use and when to use or. It depends on whether the inequality is less than or greater than the number. For less than or equal to, you get a single continuous range, so you use and. For greater than or equal to, you get two separate ranges, so you use or. Another tricky part is understanding why the greater than case splits into two parts. It's because the absolute value measures distance from 0. If the distance is more than a certain number, the variable can be far to the left or far to the right on the number line. That's why the solution involves two separate intervals. It's also important to remember that absolute value can never be negative. So, if you see an inequality where the absolute value is less than a negative number, it means there is no solution. For example, the absolute value of any number can't be less than -5. That's a common mistake students make, but it's a quick way to check if the inequality makes sense. To solve these inequalities clearly, start by isolating the absolute value. Then, check if the inequality is less than or equal to or greater than or equal to a number. For less than or equal to, write a single compound inequality with and. For greater than or equal to, split into two inequalities with or. Solve each part separately, and then combine the solutions. Understanding the geometric meaning of absolute value as distance from 0 helps a lot. It shows why the and case is a single interval and the or case is two separate intervals. Recognizing this makes solving absolute value inequalities much easier and less confusing.